this is where we left off yesterday. So we said that since this is a rose, right, it radiates out as many times as there are petals. And since this is cosine of 5 theta, there are 5 petals. So what we need more than this, okay, this will be less efficient. The more efficient way to do it is figure out the values of theta that will give you the maximum radius, so the extensions of each petal, all right? Well, how do we figure that out? Since this is a cosine, we say, okay, where is the cosine equal to +1 and where is the cosine equal to -1? And we determined that cosine is equal to 1 or -1 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and so on. So here we said, okay, this is when theta is equal to 0, pi, 2 pi, 3 pi, 4 pi. How many of those do we do? 5 of them, because there are 5 petals. And now we said, okay, if cosine is 0, if cosine is 1 or -1 at these angles, the angle here is 5 theta. So I say 5 theta is equal to 0, pi, 2 pi, 3 pi, 4 pi, and I solve for theta. We're good so far? Okay. The one additional thing you have to do is this. Figure out at each of these, is the cosine going to be positive or negative? So for example, at 0, cosine is +1, right? At pi, cosine is -1. At 2 pi, cosine is +1. Okay? Just like the basic cosine that we know from chapter 4. Okay, now we're going to go ahead and graph these. So I'm going to graph the ones that I've put in the red rectangle. Okay, so at theta equals 0, the radius is 1. In order to see it better, I'm going to recalibrate this. So I'm going to make this 1 and this 2, right? Just so it's not too tiny. Does that make sense? I'm going to go up by 2s. All right, so at theta equals 0, my value is 1. Theta equals 0 right here. Does everybody agree that that's right there? Okay. The next point is theta equals pi over 5. Where is pi over 5? Is it before pi over 6 or after? It's after pi over 6. But over there, is the value +1 or -1? Negative. That means I'm not going to put the point up here. I'm going to put it down there. You see what that means? Does everybody follow me there?
But how do you know if it's positive?
Well, because how did we get pi over 5? It came from 5 theta equals pi, right? What's cosine of pi? It's -1. All right? So that's going to go between the 6 and the 3, and it's going to be -1 right there. Okay? Now, all I care about really is that it's between the 6 and the 3. It doesn't have to be like NASA precise. Okay? Now, the next one is 2 pi over 3. It's positive at 2 pi over 3, +1. So I'm going to put a point here. Okay? Everybody agree with me on that one? Okay. The next. Oh, is it 2 pi over 5? Yes, it's 2 pi over 5. Where is 2 pi over 5? Is it greater than 2 pi over 3 or less than 2 pi over 3? Less than.
It's in between pi over 2 and 2 pi over 3.
Yes. Pi over 5. Pi over 5. Okay. The next one is 3 pi over 5, and it's negative there. So where is 3 pi over 5?
In between pi over 3.
So 3 pi over 5, it's between, so it's between 3 pi over 4, which is 3/4 of a pi, and 3 pi over 6, right, which is pi over 2. Does that make sense? Mm-hmm. Okay, so where would that go, though? Is it positive or negative? Negative. So it's here. Okay, and then what's the next one? 4 pi over 5. 4 pi over 5 is just under a pi, and that's positive 1, so it goes over there. Okay? Now, once we do this, we do our petals. It's okay. Okay? Once we do that, we do our petals. So the thing is, I'll talk about that right now. Okay. So r equals 2 theta. This one, the radius goes twice as fast as theta. Okay? So what I'm gonna do here is I'm gonna label these to go 2, 4, 6, 8. Okay? Now, when r is equal to 0, how much is theta? 0. When r is equal to pi, let's say, how much is theta? I'm sorry, when theta is equal to pi, how much is r? Here, when theta, it's 2 pi, which is how much? 6.28, right? So at 0, we're at 0. When we're at pi,
oh, is this a spiral?
Yeah, when we're at pi, it's 6.28. So somewhere over here, 2, 4, 6, here. When we're at pi over 2, how much is here? When we're at pi over 2, how much is r? R is pi, which is 3.14, right? 1, 2, 3.14, right there. When we're at pi over 4, how much is... It's pi over 2, which is how much? How much is pi over 2 in decimals?
1.5.
1.57. So that would be 1.57 here at pi over 4. Okay? So what happens is with each one, it goes radially further and further out. Okay? At 3 pi over 2, how much would it be? It'll be 3 pi, which is... How much is 3 pi? It's greater than 9, right? So it's going to go above here. So it's just going to spiral. Okay, so at each step, it just spirals out. Okay? All right, so determining maximum R value. This is the furthest point the graph will reach from the pole. So another way to look at it is this is where absolute value of R is a maximum. So look at this one. R squared is equal to 8 sine 2 theta, right? What shape would that be? Here. R squared is equal to something or other. It's this one down here, right? A lemniscate. So this is what it's going to look like, right? So now we know what it's going to look like. Okay, so what we need to find is the symmetry, the zeros, and the maximum R values. So let's talk about symmetry. So if you think about this for a minute, if you think about this equation, how do we test for symmetry? We're either going to be able to switch theta to negative theta, R to negative R, or both. So in this case, if I make theta negative theta, do I get the same equation back?
No.
No, why not? Because it's a sine, right? So if theta was negative theta, I would get 8 sine negative 2 theta, and that's not my original equation. So what if I made R negative R? Would I get the same equation back? Yeah. So R squared is equal to 8 sine theta. Yeah. Okay, so remember where our symmetries were? So if R is and if switching R to negative R gets us the same equation back, it's symmetric around the pole. And you can see here, a lemniscate is definitely symmetric around the pole. So symmetry around the pole. All right, so what else do we need? We need the zeros of this, right? Okay, so to find zeros, we do what we always did. So 8 sine 2 theta is going to equal 0, right? So how do we solve this one? Sine of 2 theta is equal to 0. Where is sine 0? It's 0 at, yeah, so sine is 0 at 0 pi, 2 pi. So we say 2 theta is equal to 0, pi, 2 pi, and so on. So theta is 0, pi over 2, and pi. Everybody okay with how we get this one? Okay? Yes? Okay. All right, now, maximum R values, right? Okay, so the maximum R values, there are several ways to do it. Mathematically speaking, this is a sine. Where is it going to be a maximum? When sine is equal to plus or minus 1, right? And for what values of theta does that occur? Pi over 2 and 3 pi over 2. Those are where it extends radially outward. Now, if you want the maximum R value itself, the maximum R value is how far out this thing extends, okay? So guess what? Take a look at this, okay? Take a look at this. I will provide you guys with this sheet. Look at what it says. What is A? A is this distance, right? A is the distance from 0 to the outer part. And in the equation, do you see where A is? It's R squared equals A squared. So if you match that to here, so A squared is equal to 8, okay? So A is plus or minus 2 root 2, okay? So the maximum value of R is 2 root 2. That means the most it extends from the origin is a value of 2 root 2. So for practical purposes, that's all you need. Now, in order to graph this, you need to figure out for what values of theta is R a maximum. Okay? So remember we just said this is a sine, and the sine is the maximum at pi over 2 and 3 pi over 2. Okay, so in this case, this is R squared is equal to something. So is R squared, is this value ever going to be a positive? Is it ever going to be a negative? No. So we take sine of theta is equal to 1 at pi over 2. Sine of theta is equal to negative 1 at 3 pi over 2. But do we want the negative 1 value? We don't want the negative 1 value because we don't want our equation to ever be negative. Since it's R squared, it's always got to be positive. Okay? So the values that this happens then is that theta equals pi over 2. Okay? Okay, when sine of theta is 1 when it's pi over 2, right, when the angle is pi over 2. What is the angle in this problem? 8 sine 2 theta. So I say 2 theta is equal to pi over 2. Theta is equal to pi over 4. The value of R is 2 root 2. That means R is plus or minus 2 root 2. Remember, it's R squared. This equation is R squared. There are two values of it. So at pi over 4, which is here, it's 2 root 2 somewhere here, and negative 2 root 2 here. And we said it's 0 at 0. So that's what it looks like. Okay? So what happens here is this. As you progress through your pi over 2, this is what happens. Watch. At 0, it's 0. Okay? At pi over 4, we said here it's 2 root 2. At pi over 2, it's 0 again. So look, we're mapping this out. You see that? And then at this angle, it's a maximum. And then when we go back to 3 pi over 2, it's 0 again. Okay? Here, it's going to be 0 again. Okay? All right. Okay, so let me